Hello, my Math 10 class. Welcome to the March 18 lesson, okay? Today we're going to do 3.6 and 3.7. On 3.6, we're going to learn about rational functions. What's a rational function first? Rational function basically is a function made up by a fraction, okay? This fraction is a polynomial on the top and polynomial on the bottom. And so you get polynomial over polynomial. So let's say the first polynomial looks like this format. I didn't write everything because we don't need it. And with an n degree, and this one's a bm with an m degree. So this is a rational function. You can see the polynomial on the top and polynomial on the bottom. Now, because a rational function, there's always an asymptote. Okay, asymptote, what's an asymptote? Asymptote means a line that you cannot cross. Okay, but horizontal asymptote you can cross on the x-intercept, but the vertical asymptote you cannot cross. So the first one, how do we find vertical asymptote? Okay, vertical asymptote means you're going to let the denominator equal 0, okay, and then solve for x. So x equal 1 will be your vertical asymptote. Okay, that means that you cannot go over x equal 1. And then the second is the horizontal asymptote. Horizontal asymptote is usually determined by the degree. Okay, the degree for here and the degree for here. Okay, if your degree on the top is smaller than degree in the bottom, y equals 0 will be a horizontal asymptote. If your degree on the top is equal to degree on the bottom, then the coefficient here, an divided by bm, will be a horizontal asymptote. If this degree is bigger than this degree, you don't have a horizontal asymptote. What do you have? You have called a slant asymptote. So slant asymptote and horizontal asymptote, they do not appear at the same time. Okay, so one's there, then another one won't be. So now we're going to learn how to find the asymptote. How do we do it? Okay, sorry for the mess. So now we're going to learn how to find this asymptote here. So let's look at a couple problems, okay? The first problem is problem number 34. Okay, they said you are given a rational functions f of x equal to 3x squared plus 5x over x to the 4 subtract 1. They said find horizontal and vertical asymptote. Okay, just horizontal and vertical. So let's go vertical first, vertical asymptote. Okay, and we're going to let the denominator equal 0, so x4 subtract 1 equals 0. And then we're going to factor this, factor into x squared plus 1, x squared minus 1 equals 0. This level equals 0, so you can cross out. This you can continue factor. Okay, make this to be x plus 1, x minus 1 equals 0. Then x just equal to the opposite of the number, -1, opposite number is 1. So you get two vertical asymptote. Horizontal asymptote, HA. Now look at it. The degree here is a 2, the degree here is a 4. That right? So 2 is more than 4. So therefore y equals 0 is the horizontal asymptote. If you have horizontal asymptote, you do not have a slant asymptote. Okay, you can just stop like that. So that's for problem number 34. And let's look at number 36. We are given as a x equal to ax squared plus 1 over 4x squared plus 2x plus minus 6. And we're going to do the same thing, okay, for the vertical asymptote, denominator equals 0. You can see they all have a 2 here, so we're going to divide all by 2. Make it easier, so 2x squared plus x minus 3 equals 0. So we can factor this easier after you divide. And now we're going to 2x, okay, 3 here, 1 here. Looks like we want positive, so plus and minus. Okay, so that will equal 2x squared minus 2x plus 3x and minus 3. So your x equal to the opposite, 3 over 2. X equal to opposite, 1. So there are 2 vertical asymptotes. And let's see if I get any horizontal asymptote. Let's see, horizontal asymptote will be degree here and equal to that, okay, because they're same degree, okay. Same, they both are 2, so your horizontal asymptote will be y equal to a divided by 4, which is equal to 2. Again, because you have a horizontal asymptote, so you would not have a slant asymptote. So that's for point number 36. Let's try one that with a slant asymptote. Here's the problem number 42. Again, be sure to do your homework. For x equal to x third plus 3x squared over x squared minus 4. And we're going to do the vertical asymptote first again, okay. That will be denominator equals 0, so x squared minus 4 equals 0. Factor this one, x minus 2, x plus 2 equals 0. Then s equals 2 and negative 2. So that will be your vertical asymptote. For your horizontal asymptote, and we're going to look at the degree. Look at this. This degree is higher than that, so therefore there's none. Instead, you will go into the slant asymptote. How do you do it? You take this one, x cubed plus 3x squared divided by x squared minus 4. That's when we're going to use our non-division, okay? So x squared need to become x cubed, so x squared times by x equal x cubed, so we put x here. X squared, so this is x cubed, and then minus 4x. And so you don't have x, so they put 0x here. And subtraction become addition, it was the sign. Okay, so that become 0. 3x squared plus 4x. You're going to add 3 here to make it to be 3x squared, okay? And then rest of it, you don't need to do it because you just need to look at the quotient. So your slant asymptote will be, you put equal to y is equal to x plus 3, okay? So that is your slant asymptote. And it's just a quotient for the long division. Now, let's try another one. This time we're going to learn how to graph by using this use the asymptote to graph. It's pretty easy. Rational functions are very easy to graph. Let's look at problem number 44. Okay, number 44. We are given, it's a graph for x equal to 2x plus 6 and then negative 6x plus 3. 2x plus 6 negative 6x plus 3. So the first thing we should do is to find all the asymptote first, okay? Or you know what? I changed my mind. I'm going to find the intercept first. X-intercept. That's y equals 0. Okay, y equals 0. That means this equals 0. Well, if this one equals 0, the only thing can be 0 is on the top because bottom cannot be 0, right? So that means 2x plus 6 equals 0. Because 0 divided by that equals 0 because they want this number to be 0. Then solve this one. Subtract 6 on both sides. X equal to -3. Divide by 2. Okay. So you have an x-intercept. And then y-intercept. And we go net x equals 0. X equals 0, so 0, 0. So your y-intercept in y will equal to 6 divided by 3 equal 2. Second step, we're going to see all the asymptote. So vertical asymptote first. And that will be this equal 0. Subtract 3 on both sides, so -6x equal -3, x equal to 1/2. So there's a vertical asymptote x equal 1/2. And then once you get there, you might want to start a graph, okay? Vertical asymptote, we're going to use a red color. Let's say this is 1/2. And right here, okay? Now, horizontal asymptote. Same degree, both are degree 1, so therefore your y is equal to 2 divided by -6 equal -1/3. -1 right there, so -1/3 is a little bit smaller. So this is y equal -1/3. This is x equal to 1/2. Now, the last thing is we pinpoint our intercept point, okay? X equal -3, 1, 2, 3, right here. There's a one intercept point. And then y-intercept is y equal 2, okay? So, now I know that on this side, the graph going to be like this. According to intercept point. Why are they like that? Because the graph will always try to go to the asymptote. Okay, that's how they behave. They also want to go to asymptote. So that's why they will try to get closer to it. Okay, they get closer to it, but they cannot cross it. Now the last thing is we want to know is the second half of the graph will be here or here. Very likely here. Why? Because they use the symmetry. Okay. But we are not sure yet, so we pick one point. We're going to pick a point from here. So this is a 1 here, because this is a 1/2. So I pick a point 1. I just want to know where I'm here or here, okay? S equal to 1, you come here, 1 plus 2 plus 6 equal 8. This is -6 plus 3 equal -3, so it's a negative. So 8 over -3, okay? So you notice in the bottom here, okay? When you go 1, -8 over 3, so about right here. So again, they cannot cross the asymptote, so they're going to get really close to it. So that's how you graph that. And graph rational function is very easy. You know, you just watch the asymptote, watch the x-intercept, and then you pick one point to see where your graph is located in the bottom. They want to go really close to asymptote, okay? That's for point number 44. Now we're going to try another one. We're going to try point number 15.2. Okay, 15.2. Also graph. This time we're going to graph SX. This is 15.2. As x equal to x plus 2 over x plus 3 and then x minus 1. So this time we do the same thing. So I'm going to just erase this part. Okay, the first is we're going to get x-intercept. Well, x-intercept is y equals 0. So that means this equals 0. So that's the top equals 0. Okay, it's easier for rational function. You don't have to, do the difficult way. Just go, okay, then if this equals 0, then the top equals 0. Okay, and then x equals -2. And then for the y-intercept, it's x equals 0. Okay, when x equals 0, so that will be 0, 0, 0. So 2 divided by 3. So y is equal to 2 divided by 3 times -1, so it's a -2/3. And I need to erase this one, erase the picture from the last class, last problems. Vertical asymptote again. So vertical asymptote is this equals 0. X plus 3 times by x minus 1 equals 0. Then x equals to -3 and then 1. Okay? And horizontal asymptote, look at this. This is x times x is x squared. Is that right? So the degree is 2. Okay? So therefore, this one is smaller than the degree in the bottom. So 1 and 2 here. So therefore, your horizontal asymptote is y equals 0. And then now we're going to graph. Pinpoint your asymptote first, always. So y equals 0 is just this one. Okay. S equals -3, 1, 2, 3. S equals 1. And then pinpoint your intercept point. Okay. X-intercept x equals -2. Y equals -2/3, so this is 1. And then I know that for the rational function, okay, the behavior always like very close to the asymptote from the other one, then go close here. So they go through the intercept point, they want to be very close to asymptote. It cannot be go this way because there's no more testing, no more intercept point, okay? So that's how it goes. Now the last one is that you want to know what about on here, right? What are you gonna do? So we pick a couple points, okay? So what should we pick? We can pick this is -3 here, okay, -3. We can pick -4. Okay, want to see if here or here. This one is a 1, so we can pick 2. And I did it ahead of time. So this is a -2/5. Okay, I put it inside here. And the next one is a 4/5. So that means when s equals -4, y is equal to -3. So it's a right bottom. So that means that they have to be like this. Okay? Because the asymptote here, so it cannot go over unless you have an intercept point. But you don't have an intercept point, then you cannot go over. And then now on these sides, the 2 is a 4/5, so like this. Okay, they kind of like balance each other out. Okay, like this, balance each other out on the graph. And that's how you do on this problem. Okay, and then I'm going to try one with the Slant Asymptote. That will be problem number 70. R for x equal to x squared plus 2x over x minus 1. So we do the same thing. Okay, we're going to first find the x-intercept by let y equal 0. So then, well, guess what happened here? Then with this equals 0, right? So x squared plus 2x equals 0. Now you're going to factor out the x. And then we can solve for x. So x equals 0. And then -2. So that's the x-intercept. And the y-intercept, and then that would be x equals 0. Well, it looks like x equals 0, then y is also equal to 0. So the y-intercept is just a 0, 0. For the vertical asymptote, x minus 1 equals 0. Okay, x minus 1 equals 0 and x equals 1. And for let's see, do I have a horizontal asymptote? Well, the degree here is bigger than that, so therefore there's no horizontal asymptote. That means you're going to have slant asymptote. And slant asymptote, how do I do it? Okay, I need to divide it. Okay, I don't have a room here, so I'm going to use this part. Okay, so I take x squared plus 2x divided by x minus 1. And you can see that we put x here. Okay, x times x is x squared minus x. Subtraction become addition, reverse the sign. Okay, so that becomes 3x. Now I just need to S3 here. Okay, I don't need to worry about the rest of it. Okay, I just need to worry about the quotient. So y equals x plus 3. Now I'm going to graph. Okay. Well, I graph y equals x plus 3 first. That's the hardest one to graph. So that would be x, you go to 1, 2, 3, okay? That's your y-intercept, and then you go, the slope equal 1, so it means 1 on the right, and 1 on the run, 1 on the right, okay? So that's a slant asymptote. And then your vertical asymptote is s equal 1. Oh, this is the wrong here. Just x equal 1. Okay, now your intercept point, x0, -2, right here. Your y-intercept is right here. Okay, now here's the problem. I know that this graph going to be like this because they cannot go over the asymptote, right? Be like that, but you just don't know how high this one goes. Probably it's about this high. I wouldn't think can go higher than this, the top line. But just to be sure, we pick a couple points. Okay, and I'm gonna pick -1 because this is -2 here, so I put -1. And then on this side, I want to pick a point here. I want to know for they very likely going to be on the other side because they remember I said they use the opposite and symmetric to each other. So I pick a point at 2 because it's a 1, so I pick a 2. So when I put -1 here, it comes out equal to 1/2. 1/2. So it's this is 1 here, so 1/2 is right here. And when I pick 2, it comes out equal to 8. 8 is right on the top, so it's going to be someplace like this. Well, how do I know it's not here, it's not here, it's to be here? Because they use the symmetry, okay? So they're all inside, they kind of like face each other. So that's for today's lesson on 3.6, okay? Be sure to do your homework, and then I'm going to do a 3.7.